Hello, yeah, in this video, I will walk you through the steps of performing t-tests and binomial proportion tests. Okay. First, let's try the one sample t-test. So let's generate the data. First, we set a random seed for reproducibility, and then we draw a random sample of size 10 from the normal distribution with the true mean 65, standard deviation 3. And once we have the data, the R syntax for performing a one sample t-test is very easy. Just do t.test and then the sample data. And then mu equal to 64. 64 is the hypothesis value. Okay, so R will calculate the t-statistic degree of freedom, the p-value, and print out alternative hypothesis. And 95% confidence interval for the true population mean and also the sample estimate of the population mean. So based on the p-value of 0.2092, we can already tell the difference between the sample mean and the true mean. Okay. All right, next one is the two-sample t-test, which is also called independent sample t-test. And this test compares the means of two independent groups. And what you need is to have two random samples, each from one population. Okay. So here let's set another random seed, and we generate sample data set for group A. It has a sample size of 15, mean is 60, and standard deviation 5. And group B is also sample size 15 for the normal distribution of mean 63, standard deviation of 5. Okay. And before we go further, we need to decide whether we want the equal variance version or the unequal variance version, okay, of the two sample t-test. We can do a variance test, which is implemented in the R function var.test. So the use of var.test is you put group A and group B in there, and you can specify the alternative hypothesis one-sided test or two-sided test. Okay. So here we specify a two-sided test, and you can see the p-value is 0.463. It's large, so we fail to reject the null hypothesis of equal variances. So we perform the independent or the two-sample t-test using the equal variance version. And to do that, we use the t-dot test. Now you have group A and group B. You put in two data sets in there. And then you have to specify var.equal to true. So this is really needed if you want to perform an equal variance two-sample t-test. Okay? And again, R will compute the t-statistic, the degree of freedom, and the p-value, print out alternative hypothesis, and the 95% confidence interval for the mean differences here. Okay? And also give you the sample means of x and y. Okay. All right. The p-value is 0.06, so it's very close to 0.05. So if you really want to use 0.05, you can say we fail to reject the null, but sometimes we say this is like marginally significant. Okay, so next one is a paired t-test. Remember, this is for comparing the means of two related groups, such as a pre-test, a post-test. And for paired t-test, you must have paired sample. So the sample size in the two groups must be equal. Okay. So here's another random seed we set, and we generate before treatment a random sample of sample size 12 from normal distribution mean 75, standard deviation 4. The after treatment, similarly, but it's same sample size, 12. Okay. And then you can perform the pair t-test still using the t-dot test function. So t-dot test before treatment, after treatment, then you have to specify paired equal to true. Okay. And it gives you this result. And here, the p-value is very small, so indicating there is a significant difference pre and post test. Okay, next one is the two sample t-set unequal variance. And this is, you know, the two sample have very different sample variances. So maybe you can perform the VAR test, hypothesis test, and it tells you the two variances are different. Then you can use this two sample t-test with unequal variances. So here set random seed, group C and group D. To really use the variance, unequal variance version of t-test, you can use t-dot test, but then you can specify var dot equal to false. Okay? But actually, this is the default. If even you don't do this, it will do the unequal variance version. Okay. Okay. The next one is the binomial proportion test, and we can do a one sample binomial proportion test. This is for testing whether the sample proportion from the sample proportion, whether the true binomial proportion equal to a hypothesis of the value. Okay. For example, if a coin is supposed to land heads 50% of the time, basically whether that is a fair coin or not. Okay. So what you need is three parameters. One is the number of successes, for example, the heads of the coins, and then number of trials. Here we specify as 100, the total number of trials, and then the null hypothesis. The hypothesis value for the probability of success. The P of null, we specify 0.05. Then the binomial proportion for one sample, we can use the binom dot test. Okay, and you simply put in the success and trials and P null. Okay, and this tells you the results. Again, we get the sample. We get the number of successes and number of trials and p-value, alternative hypotheses, and 95% confidence intervals. As you can see, like the t-test, we can get confidence intervals also. Okay. And the sample estimate, the sample proportion. And for this test, the p-value is also marginally significant. Okay. And for two sample binomial proportion test, you need two samples. For example, you have a group 1 in which you have 30 successes out of 50 trials. In group 2, you have 45 successes out of 60 trials. And you want to test if the probability of successes in these two groups are equal or not. Okay. And you can generate success group 1 and trial group 1, success group 2 and trial group 2. Oh, we forgot to specify random seed. Okay, but anyway. And then you use the prop.test function in R. The syntax is simply use prop.test and you use C. You combine the successes, number of successes, number of trials together. And then this gives you all the results of the two sample test for equality of proportions with continuity correction. Okay, so then you can see the chi-square statistic, the degree of freedom, the p-value, alternative hypothesis, and the 95% confidence interval for the difference of the two binomial proportions, and also the sample estimates, the sample proportions. Okay. All right. Thanks for watching, and this is how you do t-tests and binomial proportion tests.